Um, you can be a monopolist in a small market and a price taker in a bigger market. Totally, yes.
Like you can be price taker for like your inputs market, right? Like you can be a price taker for in the case of like the milk you need for the butter, but then monopolist in your final product. That's
You
what
could.
I'm saying.
Yes. And then also, then how beautiful your monopoly is, you know, you could also have monopolistic competition, which means you have a limit of monopoly power, but your monopoly power is limited, right? Because you have monopoly over a very special product. Like in your case, you were doing the garlic butter, maybe somebody else was doing rosemary butter, somebody else was doing garlic butter in a different neighborhood, etc., etc. And each of you have like a little bit of pricing power. You could decide to price lower or higher, and your demand would change.
Also, for example, a case in here would be a company that is the only local producer in a market with tariffs, no? Because then all the foreign ones will have to pay the taxes. So you don't have, like, technically a monopoly, but you have more power because you can set the prices up to at least the tariffs.
Well, no. I mean, the tariffs don't really give you monopoly power. They may affect the equilibrium price, but in the end, there's going to be an equilibrium price for consumers. It's going to be the same for one, and you're not going to modify that equilibrium price unless you have concentrated market. Okay, good. So let's do the kind of monopoly part. Many of you may, like the ones that took economics before, probably saw this. So you're thinking, well, first of all, let's talk about like revenue. Right? This is kind of like you're going to gain a bit of intuition on those two terms of the first order condition, right? So I have quantity and price. Suppose my demand is something like this, like linear. What's my revenue? If I sell quantity, if I sell this quantity, then my price is going to be high, right? And my revenue is going to be this rectangle. If it is square, then and then if my quantity is, if my quantity is high, my price is low, right? I have to say low price in order to sell the product, right? So the firm knows that basically has this trade-off. Right? You can sell a high price, but it's not going to sell that much. Or you could sell a low price and sell a lot. For a low price. And the revenue is going to be this area, right? So if I increase the quantity by 1 unit, my revenue increases by the price I get, right? This is like the first term or the second term here of the condition. Right? I get this extra wider rectangle. That's the P of Q term, but my rectangle becomes a little bit shorter. That's the P prime. By how much? By P prime of Q. And then the change in the revenue is this P prime of Q times the size, the base of the rectangle, Q. You see what I mean? So if I increase the quantity, basically I get a rectangle that's a little bit wider, that's P, and then I get a rectangle that's a little bit shorter, right? That's P prime times Q. Change of value. Okay, and then the question is like which is the largest rectangle that I can draw under the demand curve? It's going to be the one that maximizes the revenue, right? So it's going to be one where like P prime of Q times Q plus P of Q equals 0. This is not the same as profit maximization, it's just revenue maximization, right? And with linear demands, that's going to be exactly at the half of the triangle. Doesn't mean it's a square because the triangle doesn't have to have slope 1, right? Or is it a square? I don't think it is. But you see, anyway, this is just like a particular result for linear demands. The important thing is like the idea that basically what we're trying to do here first is we're trying to get like the rectangle that's the best possible with this trade-off, right? Like we have like low price. If I set a very low price here, this rectangle is not gonna have a very big area. You know, it's like I'm selling the most, right? I'm not trying to sell as much as I can because then I have to reduce the price too much. I'm also not trying to set the price as high as I can, so because then I will sell almost anything, right? So there's something in the middle. Hi, guys. I gotta tell you something. The professor talked to me yesterday, and he was kind of worried about the lateness of the math students. Not normal and not professional. So it doesn't really bother me that much, but I think it bothers our professors. I guess as the director of the math, I have to tell you, no, seriously, no, I'm not joking now. I'm always joking, but not now. That it's very important for the program and for you to be early in class and show up to class on time, and in general have a professional attitude. Thank you for your attention to this matter. Especially for professors who are coming from outside of the University of Navarra, right? Somebody comes, travels here. This was actually a professor from me, but especially I think like if somebody comes from another university and travels all the way here, you know, to teach, it's nice for them to, it's nice to them to show up early to class. And it's also good for you because then you get to see the whole class. And the class starts earlier and you learn more. And the program will go better. But I think it's going to generate like positive externalities. That's it. And there's negative externalities when people show up late. And then it's a bit of a free rider problem because it's like if two people show up late, suddenly like the guy like or girl like the professor is like already done like okay this group what's the deal, they show up late. Maybe if like 80% of the class was on time. So everybody needs to kind of like internalize and make it a personal thing to be on time for class. All right. Okay, so revenue maximization. But of course, revenue maximization is not the end of the story, because we're not trying to set the highest possible price. We're not trying to sell the biggest possible quantity and have as many sales as possible. You know, some marketing people will tell you like that's what they do, and that's what companies do. But it can't be what they do, because if you wanted to do that, you'd set a price of zero. Right? In our world of economics, clearly that's not the case. We don't know much about marketing in practice, and we're not gonna be there like increasing the sales of companies. Exactly, I don't know how to do it. Doesn't matter, but conceptually, clearly that's not the case. Okay, we know that. That's from pure reason and logic. And the companies also, it cannot be the case that they're just trying to maximize revenue, okay, price times quantity. Because the companies have costs, and our logic and reason and minds tell us that they also have to take that into account. The profit maximizers, right? So they're not gonna say marginal revenue equal to zero. They're gonna say marginal profit, which is marginal revenue, minus marginal cost equal to zero, right? So that's marginal revenue equal marginal cost. Because in Sarkozy, I'm probably gonna produce a smaller quantity than if I were just trying to maximize marginal revenue. There's some special cases where we may assume that the marginal cost is zero, always, and there we're doing maximization. Okay, so how does a marginal profit maximizing monopolist look like graphically? Basically, we have quantity and price, right? And we have a demand function. Let's say it's linear, right? So this is P of Q. There's a cost function, marginal cost function, right? So this is marginal cost. And where's the monopoly is going to price. Well, marginal revenue plus marginal cost, right? So where's the marginal revenue? Well, I do the demand as linear, so let's say that the inverse demand P of Q equals A minus BQ. Then marginal revenue is P of Q times Q. It's the derivative of P of Q times Q divided by Q. So it's the derivative of A times Q minus B times Q squared by Q, which is A minus 2 times B times Q. Okay, so basically this is A, and the slope of this is minus B. And that's kind of like the same function, like starts at A, but then it has a slope of 2, minus 2, right? So it's going to be like, kind of like dissecting this triangle in half. Okay, so that's my marginal revenue. That's P prime of Q times Q plus P of Q. Can you explain that? So that's the equation for P times Q, right? Well, I'm just saying I'm doing linear demands here. I do this linear, so P of Q is A minus B times Q. And then the derivative of revenue with respect to quantity, the marginal revenue, this is marginal revenue, is A minus 2 BQ.
Because the revenue would be AQ minus BQ squared.
And I mean, this is P prime of Q times Q plus P of Q. Right? Just in the linear case, that's A minus 2 BQ. Okay, and that's so we know that it look like this. If it were non-linear, it would look similar, but not exactly that in half. It would be more or less a line curve that would be cutting the curve in half, more or less. In general, right? Generally speaking, not always. You see what I mean? But in the linear case, it's like exactly cutting in half. So just to draw things nicely, let's do a linear for the drawing. And all the intuitions here kind of generalize to non-linear case. Okay, so now we have it. Marginal revenue equal marginal cost, right? So that's here. The monopoly quantity is going to be QM, or marginal revenue plus marginal cost.
Charges, huh?
What's the monopoly price? It's P of Q. So where's P of Q? It's here, right? So this is P. P of Q are not Q. And where would be the competitive price? Would be we're pricing per marginal cost. Right? Without monopoly power, if the firm were a price taker, it would send the quantity Q star, and the price would be P of Q star or P star. We don't have any colors, any color chalk here, so this is going to be a bit messy.
Straight lines and dash lines, maybe.
I can do something. So okay, but I'll just like kind of like I'll do what I can. Okay, but basically, what are the profits of the firm if the firm is competitive?
P times Q minus C prime.
It's P star times Q star minus C of Q star. Okay, but and here, where will we see that? C of Q star is the integral of C prime, absence fixed cost, of the variable profits of the firm would be, it's like, one way to think about it is like each unit that the firm sells, it gets the price of P star, and it costs the firm C prime, right? The C prime curve. So it's like the first unit that the firm sells, they make this, and it goes to this, right? So that's like one unit. And then you have the second unit, and then the star, and it goes to this, and then like, you start selling more units here, right? Until you get to Q star, right? And the last unit goes to this C prime of Q star, and you get B star, right? And then after that, the firm is gonna produce those units because they will cost more than B star, right? So the overall profit that the firm gets is the integral of all these units that it's selling between 0 and Q star of B star minus C prime of Q. Okay, and that's this area here. Okay? And now with monopoly, it's the same story, but I'm not going to put something to star, and my price is going to be star. My price is going to be PM, and I'm going to produce between 0 and QM. So it's going to be like the first unit is going to cost me this, but I'm going to charge the price up to here, right? And the second unit is going to cost me this, but I'm going to charge the price up to here, right? And so on, and all the way up to here, right? So each unit, I make more per unit, right? Because now my profit per unit are these parts are higher. But I sell these units. That's the trade-off that the monopoly faces. Okay? But look at this. The monopolist has gained like this whole rectangle here, right? Compared to the competitive firm, and it's only lost this the curved triangle over here. Right? And the rectangle is bigger than the triangle, right? And we know that has to be the case because this is the profit maximizing quantity, right? Okay. And so the profits go up with monopoly. The monopoly is basically producing a little bit less, kind of restricting the quantity, a little bit on purpose to drive the price up. Even though it's producing fewer units and it's kind of like foregoing the profits from producing these units, it gets enough profits from driving the price up for all the other units that it more than compensates for that, right? So it restricts the quantity on purpose because it internalizes the fact that producing more units will reduce the price on all these inframarginal units. Okay, and what about the consumers? Consumers lose what? They lose this triangle, right? So remember, the inverse demand curve is willingness to pay, right? So for the producers, it's clear that we're measuring profits. For the consumers, what are we measuring? We're measuring the difference between how much you were willing to pay for a unit and how much you ended up paying. That's your value that you're getting from buying the product, right? So if I was willing to pay $10 for your battery, and you sell it to me at 5, this particular consumer, gets a value from this transaction of $5 because it has a value for me of 10 in terms of like how much I'm willing to pay for it, willingness to pay, right? And this solution is for 5, good deal. For me. Right? For me, good deal. Now the consumer, the last consumer that has a willingness to pay of 5 and still buys it, right? Gets like consumer surplus, gets like the value from the transaction of 0, right? They're like, okay, I could buy it or not. For them, not so good. Consumer that has a willingness to pay of 70.
Yeah.
Remember?
Can I change?
Why?
It's a little bit high, I guess.
Yeah, okay.
Yeah.
Okay, you can change it.
It's
How
like
much?
it's like it's 17, I guess.
17.
Yeah.
Okay, so willingness to pay of 17, you pay 5. How much value do you get from the transaction in monetary terms?
5?
You pay 5.
No.
You are willing to pay 17. You pay 5.
No. It's like I pay 17 to 17.
You are willing to pay 17.
Yeah, I'm
For
willing.
you, the product, to me, that tells me, an expert economist, that the utility measured in money of the product for you is $17. But then you have to pay 5, so you lose 5. You get?
Nah.
No, you get 12.
You get 12.
So consumer service.
You said 12, right?
Yeah.
So he gets 12, right? In terms of value of his transaction. I get 5, he gets 0, because he was, for you the value was 5, right? I'm not making this up, it doesn't matter.
So, just question, so the big rectangle, that's for the monopoly, and the small, I don't know, triangle-ish, that's the profit max, right?
I mean, this is the quantity that maximizes the profits. The profits are the area between 0 and the quantity, and between the price and the marginal cost, right? It's like this integral between these curves of the price and marginal cost over the interval between 0 and the quantity, right?
So the color rectangle that you just arc, that represents the profit, right? The P&M.
These are the profits and the monopoly, these
Okay.
part here,
Yeah, that's-
right?
And the other one is.
And these are the profits and the perfect competition. Perfect competition chooses a higher quantity, right? And that means a lower price. That means that the interval is taken between that lower price and between that lower price and the marginal cost curve, but over a bigger interval. Okay? Okay, we can write down these intervals as well. Let's write them down. Okay, but before we write them down, let's think a bit about the consumer side, right? The consumer side before was getting all these units, right? And for those units, how much value overall, if you add across consumers, were they getting? They were getting the integral between 0 and Q star of P of Q, right? Of their willingness to pay. You were summing their willingness to pay, but then you had to subtract P star. Right? So it was the integral of their willingness to pay minus what they were paying, P star, which is 0 and Q star. Okay, so almost like this whole triangle here. Okay? I'm not gonna like shade it or anything. This triangle here. Now with monopoly, it's going to be the integral between 0 and QM, because it's a lower quantity in the purchasing. The integral of the willingness to pay minus what they pay, but now they don't pay this time. Now they pay PM. Okay? So in the end, the overall value that the consumers are getting is this integral between PM and the willingness to pay up to QM. Right? So it's going to be smaller triangle here. So this one I'm going to show you. Okay, so with monopoly they get this smaller triangle, so the consumers are missing this triangle here and this whole rectangle here. Are you confused? No? Well, I mean, what's the difference between the bigger triangle that the consumers were getting, which was like this whole thing here, and the triangle they're getting now? They got the whole part taken out, right? This part, we don't know where it went. This part went to the monopolist, right? So this was redistribution from the consumers to the monopolist. So that's not lost. This triangle didn't go anywhere. Well, it went to no one. Nobody is benefiting from the loss of this triangle. That's why this is economic loss. This is pure loss. This triangle for the consumers and this triangle for the producers. Okay? So these two triangles are called dead weight loss. It has the word dead, and that means it's bad. So that's inefficiency. Death. Oh, death is a part of life.
So the triangle, the big one is the value for, that's on the consumer's perspective, right? The big triangle.
The big triangle, which big?
The first one is.
This is what the consumers were getting, right? Before. It was the sum of all these values that the consumers were getting between the price that they were paying and their willingness to pay. Right? If I add that across consumers by doing the integral,
That's
it
under
gives me the total value that the consumers were getting. That's on consumer surplus.
That's under the perfect competition, right? The big one.
That was under perfect competition. Now, the monopolist comes, reduces the quantity from Q star to QM, and increases the price to PM. So now the consumers have a lower quantity and they have to pay more per unit. So the consumers get less. So for consumers, this is bad news. Right? Now let's write it down in kind of in integrals. I mean, let's see again. Let's say pi star, let's say the profits under perfect competition, where the integral between 0 and Q star of what? Where are the profits in the perfect competition? Is the integral between 0 and Q star of
The demand function of the demand function.
the demand function? No. I'm talking about the profits. What were the profits? The profits were in a perfect competition. Remember, it was like this area here. How do I write this area in math? Like this triangle or this big triangle down here. Whatever. It's going to be the integral of the subtraction of two functions, right? This the upper one and the lower one. The upper one is just a straight constant, like P star.
Ah,
The of Q star.
P star. So it's the integral of P star minus the cost function.
Exactly. Minus the marginal cost function.
The P star, C prime.
Of P star minus C prime of no, S, some dummy in index variable, ds. Okay. The profits under monopoly are going to be what? The integral between
Zero
Uh,
QM.
between 0 and QM. Right? I'm kind of sweeping between 0 and QM, like this area, which area, between which two lines occurs. I'm not going to do. So between
So now you have the
PM.
price of the monopolist.
PM and
Cost
the cost
function.
function.
The margin.
and the margin cost. So C prime of S, right? Yes. Using C prime of S, I could write C prime of Q.
But
Q.
choose the limit, so.
Q, because QL is here, the limit, it could be confusing, so I'm just saying S just to say, okay, S is just the variable I kind of like, I'm moving, right, as I integrate. It's just an abstract, kind of like the for loop,
Yeah.
I, right? It's like for I equal 1 to n, whatever, it's kind of like this index that I'm integrating over, okay, that I'm summing over. And it's the thing that moves inside the loop. If you want. I don't know how to explain it. Does it make sense? I could call this anything, basically. I I could call it Q. I could even call it Q, and it wouldn't even be wrong. It's just it could be a little confusing because QM is here, but QM is constant, and that Q wouldn't be constant. I just to keep it simple. For me, I prefer just to call it S. You see what I mean? I could call it I, DI. You know, just in general, we could call it S or something like that. Okay. Is that clock broken?
Yeah.
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 But completely.
So 30. Okay. Okay, whatever. Alright? Okay, so we have these intervals. I guess we could do the intervals. Like, they're not so hard. Okay, maybe it's instructive to learn. I mean, what's this interval? It's gonna be P star times Q star. Right? So that's my revenue when the price is P star and the volume is Q star minus the cost function.
So it's the interval of the cost.
It's the integral of the marginal cost. So if there's no fixed cost, so it's going to be my variable cost function, basically.
Yeah.
It's like it's the cost excluding the fixed cost, right?
Evaluated at 0 on Q star, right?
Evaluate, yeah, so it's going to the variable cost, the variable cost at 0 is the variable, so it's 0. I'm just gonna say it's the cost function, right? Evaluated as Q star. Right? So those are my profits. Right? That's P star, pi star. Makes total sense. This is the same. Right? It's usually like PM minus I times QM minus C of QM. Okay, and now what about the consumer surplus? Consumer surplus under perfect competition is going to be the integral between.
So it's between 0 and Qn.
Between 0 and Q
Q star,
star
I'm gonna clarify.
of
the demand function
the demand function.
minus P star.
Okay, so the demand function is going to be like P, the inverse demand function, right? P of S, or P of Q, if I don't remember the Q, but risking confusing everyone. P of S minus what? What do you say?
P star.
P star. Okay, PS. Consumer surplus under monopoly is equal to integral between 0 and Qm of P of S minus Q. Okay. This, I guess the integral of the integral of the inverse demand doesn't really have a name. This is not as in. The only insight that we get if we do these integrals would be just that we will get P star and Q star again. So if we add it, but we will get it with minus, right? So if we added the consumer surplus and the producer surplus, the profit, it would cancel out, right? The revenue. So actually, let's do it. Well, I mean, this kind of stuff. I don't think I've ever written this stuff out in class. But then I realized in the exam, whenever there's a question that requires saying something about like consumer surplus or total surplus, instead of just maximizing profits and solving for Nash equilibrium, people don't get it. A lot of people, most people. And it's because I don't think they have enough practice writing down these integrals and just thinking, so these integrals are easy to write, you just have to practice a little bit. I mean, this is not hard, right? Because it has an integral, maybe, so maybe in 8 weeks, you don't remember in the exam how to write the integral, but if we do it in class, maybe we would. Okay. Okay, so this is going to be the integral between 0 and Q star of P of S Vs minus P star times Q star. And this is going to be the integral between 0 and Qn of Vs minus Pm times Qn. Right? And then if I added this and this, notice that if I add this and this together, right? If I add these two, now I'm going to get the integral between 0 and Q star of Ps, or the area under willingness to pay inverse demand curve minus the cost of producing Q star. Right? And here, I'm going to get the integral, but up to Qn of P of Ps minus the cost of producing Qn. Qn is like total surplus, right? It's the sum of consumer surplus and profits. The total surplus has to go down when you go from perfect competition to monopoly, right? Because basically we know that it's the difference between now the area under this curve, right, minus this, so it's this whole total surplus with like this whole kind of triangle, right? Is the area between this and this, in between this curve and this curve, right? The marginal cost curve and the inverse demand curve. And we're comparing that to the area between these two curves and up to Qm, right? All of these units after Qm, between Qm and Q star, were increasing total surplus because the cost of producing them was lower than the willingness to pay for those units. So if we're not producing those units, because the monopolist is a jerk, and on purpose is reducing the quantity as a conspiracy to increase price, I'm talking with Lucy here. And then the monopolist has to basically kill a little bit of the market and make things worse for everyone in order to extract surplus from the consumers, to redistribute part of the value generated in the market from the consumers to him. Okay? So that's what's going on. It's like the monopolist produces an quantity, it kills this, creates this deliberate loss, inefficiency. It does it because it's good for the monopolist, because it's taking enough value from the consumers that doesn't matter that the monopolist is losing some efficiency from the point of view of the monopolist. Questions?
The total surplus is subsidizing or the sum of both?
The total surplus is the profits plus consumer surplus.
Okay, so both.
It's both. It's in case of it's price star plus consumer surplus star.
In two cases.
And in the other case it's prime M plus. That's what I did with this because I did first the two profits and then this.
But I mean, yeah, it's like total surplus, but it's not both integrals together. That's it, right?
Total
There are
surplus.
there are two total surplus.
There are two here. There's the total surplus for the perfect competitive case and the total surplus for the monopolist case.
Okay.
Right? The difference between these two, what's the difference between these two? Is what we just said in words, right? But what would it be? If we wanted to write it,
PM minus P star times Q star minus QM divided by 2.5.
I mean, the way I would write this difference, it would be like the integral between Qn and Q star, right? The delta total surplus is the integral between Qn and Q star, right? Of P of S minus C prime of S ds, right? And because the price, the willingness to pay, is above the marginal cost for the interval between the monopoly and Q star, because they're still below Q star, all of these units, this is possible. You see what I mean? If I start integrating beyond Q star, then I start getting negative difference between willingness to pay and cost, because for those it costs more than people are willing to pay. Okay. We made a big assumption in all this discussion, which is that we can interpret the inverse demand function directly as utility, measured in money, right? Willingness to pay. When we talk about willingness to pay, we are assuming that the utility function is quasi-linear. Okay, quasi-linear utility.
So, Jose, you said we were assuming there's a quasi-linear utility function? We are assuming.
Yes, we're assuming that there's a in all of these, basically, we're assuming that there's a quasi-linear utility function. Especially in the welfare analysis that we've done. You don't have to assume it for the profit maximization part, but for the welfare analysis and all of these consumer surplus and for the consumer surplus part, we're assuming that the utility function is quasi-linear. Okay? Basically, we very happily, kind of merrily, did this dance of consumer surplus and adding up consumers and the value, but there's a lot of bodies buried under this assumption. Okay? People are still doing research on this kind of. Why? I mean, quasi-linear utility, what's quasi-linear utility? It's basically the U of the quantity that you consume. Let's call this good X, right? And then there's like this good that we're talking about, the focal good X. And then we have everything else. It's like how much money you have left after buying butter, garlic butter, right? So we have the garlic butter and everything else. Right? I would say okay, you have some utility for the garlic butter, and then you get utility from how much money you have left. Right? And how much money you have left is going to be how much money you started with minus the price of the garlic butter times how much garlic butter you want. Okay, so if I put that here, then the utility maximization is going to be max U of X and M minus P times X. And that's going to be U of X, little U of X, plus M minus P times X. And the first order condition with respect to X is just going to be U prime of X equals P. Okay? And this basically is my inverse demand function. The price is equal to, I mean, you can think of a representative consumer here, and then if not, I can just like add them up across consumers, and I'm just going to be like an integral across consumers of these U primes of X equal P, and P is the same for everyone. Okay, but basically what this gives me is P as a function of how many units of quantity, price as a function of quantity, and that function has an interpretation. It is marginal utility. Okay, and marginal utility relative to what? And marginal utility here has an interpretation because it is relative. The marginal, basically, the marginal utility of good X divided by the price. We're going to normalize the price of good Y. We're normalizing here the price of good Y to 1, right? Because good Y is how much money we have left after. So we have implicitly here u prime of X. The marginal utility of good Y is also 1 divided by 1 is equal to P divided by 1, which is P of Y, right? This is the price of X. And Y. So the marginal utility is compared to the marginal utility of $1. Okay, I don't know if I'm saying it right. But that's what marginal utility says. This marginal utility is in dollar units. Right? Because if I take marginal utility here, like this, marginal utility of the big group with respect to Y, that is basically how much. Okay, to do is right. Okay, this is one way of doing it. But let's do it now in a different way. Let's do it in Lagrangian. Okay, and with the big U here. So, Lagrangian is fx and y plus lambda times m minus bx minus y. Okay, price of y is normalized to 1. It's the numerator. Now let's take first order condition of this thing. This is going to be ux marginal utility with respect to x. Minus lambda p. You can call this px if you want, just for lambda px, so we know it's the price of good x. And let's put here py, the price of good y, which we know that is going to be 1. Minus lambda px equals 0. Okay, so this is ux equals lambda times px, and uy equals lambda times py. Okay, so ux over uy is equal to px over py. This is general, right? This is basically the ratio of marginal utilities equals the relative prices, right? You guys learned this with Marcus? Yes, in the general consumer theory. Okay, so basically utility in general doesn't have like an interpretation in the general case, right? In this case, because of this particular form, it has an interpretation. Why? Because uy is the marginal utility of $1. Right? Uy is the derivative of utility with respect to $1. Right? And in this case, the marginal utility of having $1 is equal to 1. So we've normalized marginal utility here so that a change of 1 in the big utility function is the marginal utility from $1. And it's always constant. Right? So having $1 more gives you here a utility, always a utility of 1. Okay? And so, if I say having 1 unit of x increases your utility by u prime of x, u prime of x what? U prime of x dollars. Right? Because this function is measured in dollars. You see what I mean? Because basically, yes, delta u with respect to y is equal to 1, and we said that y is how many dollars you have left after you got the stuff. You see what I mean? So this means this is the part that we left out, and that implies that du dx is measured in dollars, right? Because it's measured in dollars, and dudx is equal to your prime of x, and it's also your inverse demand function, basically p of x, right? It's like p equals p of x is your prime of x. So your inverse demand function is how much utility this group gives you, this unit gives you, in dollars, right? So you can say it's your willingness to pay. It's how much dollar value you get from 1 unit of this thing. You see where this comes from? So all of this is kind of behind this. So what does this ignore? It ignores things like inequality, right?
But isn't all consumers are the same utility of the same dollar utility of the same product, but you could value the product different?
Basically, with this, it's like I'm saying, okay, everybody values $1, $1, right? Equals a linear. So then I can add people up. I can say, okay, you got a value of $12, you got a value of I got a value of $5, etc. We add all that value that we got compared to what we paid, and that's how much we got as consumers in dollars, right? I can only do that because I've already did this trick and make like heroic assumptions so that I can measure things utility in dollars. Right? You guys didn't measure utility in dollars with Marcus, I assume. You measured it in newtons, and you said newtons have no interpretation, and only the ordinal matters, right? Only the order of choices matters. But it doesn't matter. You can do like a monotonic transformation of the utility function and transform it from like it being like 10 to 100, and it doesn't matter. You see what I mean? Now I'm saying, forget about that. If I assume it was a linear, utility is in dollars for everyone, right? But obviously this is not realistic. It allows me to do this beautiful welfare analysis. I have to do it if I want to say how much are consumers benefiting as a whole. If you have a utility function, he has a different utility function, and I can't add you, right? You and him are not additive. I don't know how much you enjoy Black Bunny butter. But I know that you chose it over the other butter, so you must prefer it. Right? That's what I know, but I know how much enjoyment you get from butter. Right? And I don't know how much you enjoy it, and I don't know how much you enjoy it. So I can quantify how much overall value the consumers are getting. So I can talk about consumer surplus. Without quasi-linearity. I can do some other tricks, but they're not as nice. Okay? Of course, people have thought about this for like centuries, and they've come up with alternatives to this. But this is like the one that's like, see, I told you this whole story, and you guys didn't protest at all. So because it's like so nice, right? It's gonna say, how much are you willing to pay and all this stuff. I did the whole trick, and it works. But then after that, it's like, okay, what if somebody's willing to pay a lot, but they don't really care about the butter? It's just that the marginal utility of $1 for them is very low because they're very wealthy, right? Or somebody's not willing to pay much for the butter because the marginal utility of $1 for them is very high because they're very poor, right? So maybe somebody likes black garlic artisan butter even more than me, right? But they're not willing to pay much for it because they don't have money, right? So I come here, I'm like, hey, it would be nice to have some black garlic artisan butter, you know. I have money, you know, to kind of like buy enough butter, and I think I'll just go and like buy $5, okay, nice, you know. And then somebody else is like, no, I can't spend $5 on feeding butter, right? Because like I have a tight budget and I need to spend my money on like something with more protein or whatever. Because I have things have to add up, right? It's like I go to a grocery store and maybe I'm gonna spend like, I don't know, 600 euros a month. But like maybe somebody's like, I can't spend 600 euros a month. I mean, for a family of 4, okay. So like I'm like 6 7 years old myself. I have master, and but like somebody else could be like, look, I have to feed a family of 4 with 300 euros a month, and I have to make it work, and you can totally make it work, but you're not gonna be buying a $5 butter. You see what I mean? And can you do it? I could do it. No, it's not that hard. But it means when I ask you how much are you willing to pay for that somebody butter, I'm like $2, and if it's 5, I don't buy it. Okay, I just buy the regular store brand butter, and that's it, and it's good enough. And in the end, all your magical health benefits were probably bullshit anyway.
I know. I had a question, and in practice, how does someone get to know the willingness to pay of every single consumer?
Sorry, don't get offended. I'm sorry. I didn't mean to.
No, I mean, it was close to the restaurant. How do you get to know the exact willingness to pay of every single consumer, or do you get an average from that when you're doing this in practice?
How do we know the willingness to pay of every single consumer? Great question.
That's
You
the
know
tough
it.
part.
I mean, that's the tough part. That's the tough part. I mean, all of this is theory, right, so far. In the end, you also need to know the willingness to pay of every single consumer. So you can do it in 2 ways. You can know your consumers because you have enough experience, and in general you know more or less what they're willing to pay and what they're not, and how much you get a sense. Okay, so just by intuition and by your experience as a kind of like selling butter, since 1853, that you more or less have a sense of like how the butter industry works. And so you know what the demand is out there, and you just know because you're like a butter expert. Alternatively, you could get data, right? You could use econometrics to estimate the demand for butter, right? So then you get the inverse demand curve from the data. So, how do you estimate the demand for butter? It's a question for another day. Not because this is economic theory too. So, but I'll tell you how to do it because I used to do it. So, I'm the expert now.
Something if you no, you have to know the willingness to pay of consumers.
You need to?
That's a type of consulting. I don't know how to say.
Yeah, I guess in marketing consulting. Yeah, you could do it for marketing consulting. If you're a firm that wants to know, the demand, you can do like a marketing consultant. And if you have data, first you have to have some data. If there's data for your product, either that you collect it or that somebody else collects, then you could use that. And if there's no data for your product, you can do it.
So we just collect data and try to find the demand and then the willingness to pay for a certain product. So
Yeah, you're gonna collect data and you're gonna estimate the demand function based on your data, right? And you're gonna use some demand specification, right? There's different ways that you could write the demand that you could estimate. We'll talk about it a little bit more when we talk about product differentiation, because that's what really these things are. So we'll talk a bit about empirical stuff. And you usually also have to use an instrument in order to identify demand. You guys haven't talked about instruments. Yeah, right? You're not talking about it soon. You're taking class now with Alex Armand, right? So far you've taken econometrics evaluation, right? Which is time series econometrics, which is different from estimating demands econometrics, right? Which is also wrong. You shouldn't have taken econometrics with Alvarico, I thought. You should have taken first with Alex Armand and Miguel Angel, and then with Alvarico. But I just realized that this year because of you, so thank you. But you shouldn't have had time series before, but alright, so what's done is done. So now you're going to learn about instrumental variables, right? So the thing is, suppose you observe like a series of prices and quantities, right? For a user product in the market. This is not necessarily exactly how you're going to do it in practice, but this is an issue. This illustrates like an issue that you will face if you're trying to estimate demands in practice. Which is that suppose that you observe the following quantities and prices, right, for your value. Okay, how do I estimate the demand function?
A line that minimizes the area between the points.
I do a line that minimizes the square of the residuals between the points and the line, right? So my demand curve is upward sloping. Why?
It's the endeavor goes with
Because I didn't estimate demand, I estimated supply. Right? So if I have supply and demand, and here was my demand curve, what's happening here, I mean, the market price and quantity, are they determined by demand or supply? They're determined by both simultaneously, right? That's something that it's very hard for people to actually like grasp, right? It's easy to draw a graph. I mean, what's setting the price, demand or quantity? Demand or supply? It's both at the same time. It's like when you're cutting a paper with scissors, which blade is cutting the paper? Both, right? The scissors have two blades and they have the paper and they cut it. So here, which is the price high because of demand or because of supply?
You have to check.
It doesn't make sense. That's the question. It's like it's the intersection of demand and supply. Okay, so demand and supply determine price and quantity, and all of these points are some combination of demand and supply. So what has to be happening here? It has to be that mostly the changes over time in this market are driven because by changes, shifts in the demand curve. So by demand shocks. You see what I mean? My demand curve here is fluctuating up and down, and that's tracing out. So this is demand on day 1, on day 2, on day 3, and that's tracing out the supply curve. Okay? So if I have an instrument that measures the demand shocks, I can estimate the supply curve. If on the other hand I have an instrument that allows me to capture only changes in price, let's say, that are driven by supply shocks, then I can estimate the demand. So if I have different supplies, then I can trace the demand. No, like perfect, right? Okay? But then, first we have to learn about instrumental variables. Chase, you have it. So you choose instrumental variables. Instrumental variables are kind of a trick that helps you create a series of prices that are only capturing supply shocks, right? And clean out the part that's really by demand shocks. So if you have an instrument, you have to think of like a clever instrument. You have to like think about it, you know how to do it. Not like obvious how to do this. If you have an instrument, then in theory you can identify the demand curve. And if you have a demand curve, now you know everybody's looking this way. And if you have a theoretical, you have a measure that gives you something. Nobody says it's perfect, it's now we're empirical. It's not like you know every single customer's willingness to pay, but you have an inverse demand curve that's estimating data using hopefully an exogenous instrument for supply shocks. Okay, it's 4 p.m. Well, it's almost 1. It's almost 1. We have until 2:30. Questions on this? In practice, you're not going to do like this linear maths to estimate. Usually there is something that takes into account more like product differentiation and an estimated demand system for many goods. It becomes like an art also. So don't think that it's like what people do out there is like perfect. But in general, and everybody distrusts everyone because it's econometrics, so nobody believes. I think that in general people who have a good hand with this can tell you that estimated demand is probably okay. But it becomes like this kind of like dark art. How do you use dark arts? I'm not overpromising here, but it can be done. It can be done, but it has a lot of like asterisks, a lot of caveats. And it can be done depending on the quality of the data. Here, everything depends on the quality of the data and the existence of valid instruments. Right? You have to think of things that are shifting supply and are shifting demand, or you can use instruments alternatively that people use in the literature and that are generally accepted, more or less, depends on the instruments. There's a bunch of literature on which instruments to use and how to construct them in ways that are like with the data that's available. You can construct instruments with product characteristics and competitor characteristics and things like that. Okay, so there's a whole literature, huge, about how to do stuff. Everything is imperfect. Okay, and there's in the 90s when people started doing this stuff more. So it used to be, before we go to the break, I guess in 5 minutes, I'll tell you a bit of history of empirical work in industrial organization. It used to be, like in the 1950s, there was this guy, I think he was called Bain at Harvard, that was doing empirical work in industrial organization. Right? And what he would do is he would take measures of like from financial statements of like profitability of different industries, right? Of how much, what the profit margins were in the accounting, and then he would construct measures of how concentrated the industries were, right? Like the HHI, so indices of concentration. Right, the HHI is the sum of the market share squared. It's a measure of like the average market share of the firms weighted by market share. So it's a kind of like how concentrated the firms are in the market. And instead of be like, okay, I'm gonna see if more concentrated industries, then you have higher profits. Okay. And people did a bunch of this type of work. People also did like industry studies to select different markets of the same industry. If like the HHI was associated with profits or with higher prices. This was called the structured conduct performance paradigm. Okay, structure is the market structure, the concentration. That is, you have concentrated the firms. You look at an industry. What's the industry structure? Well, this one has like 4 firms that capture 80% of the sales, and this one has 1,000 firms to capture 80% of the sales. Right? So this one's much more concentrated than this other one. So which one would you expect there to be higher profit margins? than the concentrated one, right? So a bunch of these kind of studies. But this was highly criticized in the 1980s by this guy called Schmalensee. And eventually people were like, well, we were doing all this beautiful economic theory, all this stuff, and we're not using it, and people are doing these studies, and the HHI is not a good measure of market power at all. It's like market power depends on so many other things, as we will see. And they weren't finding very robust results anyway, so they were like, this is why we're not finding results. There's not a robust association between concentration and profitability. And it's because you guys are doing these crappy regressions, and when at this point we are sophisticated enough, we've advanced enough in economics to do better. So they created the new empirical industrial organization, kind of like the late 80s and the early 1990s. Really started with like Berry's, I don't know if it was part of his thesis, but probably Steve Berry, 1994. So Berry, 1994. Was a paper about how to estimate demands for differentiated products, and then use that to basically also how to estimate the supply side and basically have an estimated quantitative oligopoly model with differentiated products or an industry. Okay, and then you could analyze mergers and do analysis, economic analysis with that empirical model. Okay, that was the new empirical industrial organization. New empirical IO, right? Or maybe. Okay. And basically the idea was to propose a demand system. Barry proposed like a very simple and elegant one that could take to the data, and then have again on the supply side of Bertrand competition with differentiated goods. Okay, so what's the Bertrand competition with differentiated goods? We'll find out after the break. Or you guys want to do it now and we leave it early? How are you guys feeling? We need a break.
Yeah.
Just
No? Yes? Okay, so let's come back at 1:15.
1:15.
And I want
Great.
everybody here at like 1:15 exactly.